Hi guys, welcome back. Fred here at Math and Engineering. We're going to calculate a few soil properties for you today in this video. And, link in the description down below because I'm going to, we did a previous video where we just really basically explained phase diagrams and some of these properties in soil and what soil consists of. So if you want to go and watch that first, if you haven't, go ahead. We're going to solve for some properties of the soil here, okay? And on the screen, I'm going to put that up right now, is some formulas that have been derived using those relationships that we explained in the phase diagram video. And, I'm not going to go too much into the actual derivations themselves. As you know, this is a channel where we focus on solving the problems so that you can do well in the exam, not necessarily on the theory so much. We'll throw in theory when we need to, but for this, if you really want to understand the derivations and how these formulas are derived, I suggest going to your textbook and looking over the derivations. I do encourage doing that too because it's not a waste of time. Understanding where these formulas come from can help you, but in the interest of making a short video that helps you solve problems, we're not going to go over that. So, but I will put on the screen every time which formula we're using. So let's read the question. So we have a moist weight of 28.3 times 10 to the negative 4 meters cubed of soil, and we have the weight, which is 54.27 newtons. Okay, so remember the difference between mass and weight. Weight is mass times gamma water. If the moisture content is 12% and the specific gravity of soil solids is 2.72. Okay, so this is, and we're asked to find these properties. This is a really classic kind of introduction to soils question. First, we need to start by kind of labeling what it is that we have. Okay, so we have the weight, the moist weight of the soil. Okay, we're going to just say weight moist, and that's going to be equal to 54.27 Newton. Okay, we have, what else do we have? Well, we have the volume of the soil. Okay, and that is the moist volume. We'll just write M there. 28.3 times 10 to the negative 4 meter cubed. Okay, we're given the specific gravity of solids. Okay, so essentially the density of the solid portion of the soil, that's 2.72. And we have moisture content is equal to 12%. Okay, cool. So let's go ahead and let's start by solving the first question now that we've kind of outlined what it is that we've been given. Now we're asked to find the moist unit weight. Okay, we don't even need the formulas because as we know from the moist unit weight includes the water. Okay, so if it includes the water, okay, it's also obviously going to include the solids. Okay, so we know then that we're going to call it gamma, okay, is going to be equal to the weight divided by the volume. Okay, so that's going to include the water. The weight is going to be the weight of the water and the weight of the solids divided by the total volume of the sample. Okay, and we're going to get that by dividing 54.27. Okay, and we're going to convert this. This is the weight of the moist soil sample, and we're going to convert that to kilonewton. Okay, because usually when we do a question like this, we're going to express it in terms of in kilonewton per meter cubed. Okay, so we're going to multiply that by 10 to the negative 3 to make that kilonewtons. Okay, and as we have a meter cubed unit on the bottom, which is given to us, we don't need to change that. Okay, so we have 0.00283. Okay, so the moist unit weight is equal to, okay, we have 19.18 kilonewton per meter cubed. Okay, so that is our moist unit weight. Let's move on. Okay, let's go to B, and now we're asked to find the dry unit weight. Okay, so I'm going to put the formulas up on the screen. This is one that you're going to want to remember. Okay, so the dry unit weight is equal to gamma divided by 1 plus the water content. This comes up all the time in this course, and I highly suggest that you remember this formula because it does come in handy. Okay, so let's just make sure that we're getting our units right. So we have our moist unit weight here. We have 19.18. That's going to be divided by 1 plus our water content, okay? And make sure the water content is expressed as a decimal, not as a percentage. So we have 0.12. And that's going to be equal to, okay, we have 17.13. Okay, 17.13. As you'll see, when we include the water, and when we remove the water and we're just looking at the dry density, the unit weight goes down. Okay, so that's something to know there. Okay, cool. So let's move on to question C now. So we have the void ratio. Now, the void ratio, okay, I'll put the equation up on the screen that you're going to need to use for this information. So we're given specific gravity of solids, we're given gamma water, okay, and we can now apply this formula here that's highlighted. So as you'll see, okay, we're not really too focused on deriving these formulas or completely understanding what they mean. We're focused on solving the problem here, and a lot of this course, the first part of this course in soil mechanics, is going to be dedicated to you looking at these formulas and figuring out which one you need to use. And if you'll take a look at this formula here, we have gamma dry, okay, which we just solved for. We have the specific gravity of the solids, and we have gamma water, which is known, it's 9.81. Okay, and we can go ahead and rearrange and solve for E. So let's go ahead and do that. So we can say 1 plus E is equal to gamma, the specific gravity times gamma water divided by gamma dry. Okay, and if we go ahead and solve for E now, we're going to have specific gravity is 2.72 times 9.81. Make sure your units are correct here, guys. We have gamma dry, which is 17.13. So everything so far is in kilonewton. Everything is in meter cubed. This is a unitless item here, and we're going to subtract this 1 here. And if we go ahead and calculate E, we're going to get that E is simply 0.56. Cool. Okay, so our void ratio is 0.56. Let's move on to the next one. Okay, so moving on, we have our porosity. Okay, so our porosity, if we remember, I did show you this formula before. Okay, so we have N, as we know, is equal to the volume of voids divided by total volume. It's also equal to E divided by 1 plus E. So this is also kind of another one that you're probably going to want to kind of remember by heart, although you will get it on your formula sheet. Okay, and now that we have the void ratio, let's go ahead and plug it in. That's going to give us a value of 0.359. Perfect. Okay, let's take a look at our degree of saturation. And if we look at the degree of saturation from before, okay, we had volume of water divided by volume of voids. Okay, and that also can be expressed as, and if you want to know more about this derivation, let me know down below and I'll make a video to explain this stuff for you, is the water content times the specific gravity of solids divided by the void ratio. Okay, and that is simply going to be, we're given all of these, 0.12 times 2.72 over 0.56. Okay, that's going to give us a value of 0.583. Okay, or 58.3% degree of saturation. Okay, and finally, okay, we're going to solve for the volume that's occupied by water. So if we want to find the volume that's occupied by water, okay, we're going to want to know what the volume of water is, okay? So volume of water is what? Okay, so how do we do that? Well, we know that the volume of water, okay, the weight of water is equal to, okay, is the total weight minus the weight of solids, right? Because we don't include the weight of air. So all that's the total weight is equal to weight of water plus weight of solids. So if we rearrange, solve for weight of water, this is what we're going to get. Okay. So what do we have here? Well, we have total weight. Okay, but what we don't have is we don't have the weight of the solids. Okay. So the way we find weight of solids, okay, is simply the total weight divided by 1 plus the water content, right? So we're going to divide the water content out, and that should give us the weight of just the solids. So we're going to have 54.27 times 10 to the negative 3 over 1 plus 0.12. Okay, so therefore the weight of solids are equal to, okay, we have 48.46 times 10 to the negative 3 kilonewton. And if we go ahead over here, now that we have the weight of solids, we can go ahead and we can start to find the weight of water. Okay, so now we can, the weight of water is equal to, and we'll just do that in newtons, we have the weight minus the weight of solids, and that's going to give us the weight of the water. And how do we find the volume of the water? Well, it's simple. We need to know that density is equal to mass or weight divided by volume. Okay, so if we go ahead and we divide the mass by the density, that's going to give us the volume. Okay, So if we go ahead over here, and we know the density of water, okay, so we have 5.81 times 10 to the negative 3. We divide that by 9.81, density of water, that's going to give us 0.592 times 10 to the negative 3 meter cubed. Okay, so this is the volume of water that, the volume that's occupied by water within the soil sample. Okay, cool. So I hope that helped. If you want to just try and solve them on your own and then see what the answers are, that's also a good strategy. Like, as always, comment down below if this helped you. If you want to see some more derivations, let us know down below. Like and subscribe.